Use the identities for the cosine of a sum or a difference to write each expression as a function of theta. Sometimes when we are subtracting or adding two angles inside of the cosine function, one of the angles might be unknown. So we'll just call that angle theta. We can still simplify the expression using our cosine identities. Cosine of theta minus 180 degrees, so let's call this our first angle A, and this will be our first angle B. We can still use our cosine identity even though we don't know both angles. We will just write it as cosine of the first angle, which is theta, times cosine of the second angle, which is 180 degrees. And since we're subtracting on the inside, we'll be adding on the outside. Sine of theta times sine of 180 degrees. So we have cosine theta times, and we can actually figure out what is cosine of 180 degrees. So we'll think about our unit circle, and 180 degrees would be right there, and that point on the unit circle would be minus 1, 0. So cosine of 180 degrees would be the x value on the unit circle, so that would be negative 1, plus sine theta times sine of 180 degrees. And of course, that would be the y value of that point on the unit circle, so that would be 0. So we're going to multiply, and then we're going to add. Cosine theta minus 1 would be minus 1 times cosine theta, or just minus cosine theta, plus, well, 0 times anything is 0, so this whole expression becomes 0. So now I'm going to add minus cosine theta plus 0, of course, would be minus cosine theta. So sometimes it's convenient for us to take something that has an angle on the inside that we're adding or subtracting. And if I don't want my input angle to be complicated with an angle that's known and an angle that's unknown, we can use that difference identity for cosine and convert to a simpler expression. Notice that for this cosine function, the only input that we have is just theta. So it's a lot simpler input, and oftentimes that's a lot better to work with than a complicated input angle where one is known and one is unknown. We can do the same thing for a sum. So let's say that we have cosine of 270 degrees plus theta. So here we have a complicated input angle that's a sum. We have two separate angles where one is known and one is not known. And we want to convert this to something a lot simpler for us to work with as an input angle. We can do this using our cosine identity for a sum. So that would be cosine of the first angle times cosine of the second angle. Since we're adding on the inside, we're going to be subtracting, opposite sign on the outside, minus sine of the first angle times sine of the second angle. And we want to find cosine of 270, so let's think about our unit circle, and that point that would be representing 270. That would be x value of 0 and a y value of minus 1. So cosine of 270 would be the x value, so that would be 0, times cosine theta minus, let's put them in parentheses there, sine of 270 degrees would be minus 1. And we're going to be careful about something. There was a negative as part of the formula, and then sine of 270 itself was also negative. So we have two negatives there. So be careful with that. And then we don't know sine of theta, or just sine theta. And now we're going to simplify. We're going to multiply and then combine our terms. 0 times anything is always 0, so we have 0. We have a negative and a negative, so we can call that a plus 1 times sine theta. And of course, 0 plus 1 sine theta would just simplify to be sine theta. So this expression will be much, much simpler to work with than the original expression cosine 270 plus theta. We can just work with sine theta instead, since these are exactly equivalent. They're exactly the same value. We have previously discussed the cofunction identities, And remember that the cofunction identities told us one basic idea, told us that if we were looking at two angles that added up to be 90 degrees, in other words, complementary angles, so for example 30 degrees and 60 degrees, complementary angles have cosine values that are the same. So the cosine value of 30 degrees would be equal to the sine value of 60 degrees since these two angles add up to be 90 degrees. We call these complementary angles. And we also discussed the idea of our cofunction identity. When we look at the cofunction identity for cosine, it is cosine of 90 degrees minus theta equals sine theta. We notice that inside of the cosine function we are subtracting two angles where one is known and one is not known. So there is a different way that we can actually derive this cofunction identity for cosine. So we want to show that we can use our difference identity for cosine to actually show that cosine of 90 degrees minus theta is equal to sine theta. So I'm going to verify this identity by rewriting the left-hand side, and the goal will be to make it match the right-hand side. So cosine, we're going to use that difference identity, so cosine of the first angle times cosine of the second angle, plus, so if we're subtracting on the inside, we're going to be adding on the outside, plus sine of the first angle times sine of the second angle. Cosine of 90 degrees. So let's use our unit circle. We're going to pick the point that represents 90 degrees. That would be 0, 1. So the cosine value of 90 degrees is 0 times cosine theta plus sine of 90 degrees would be the y value of that point, so that would be 1 times sine theta. So we're going to multiply and then add. 0 times cosine would be 0, plus 1 times sine theta would be sine theta, and we see that we have arrived at our goal of sine theta. So there's another way that we can actually verify that cofunction identity that we have previously discussed.